Algebra 2, Lesson 5 today, page 42. I'm going to be dealing with word problems, and I want to start on 5.1, which basically begins with a word problem, and it says this: twice a number is decreased by 7, and this quantity is multiplied by 3. The result is 9 less than 10 times a number. What is the number? That always sounded to me like this: blah, 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 and blah, 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 blah equals something. And I was the kind of kid that was like, who cares? I don't want to understand this gibberish because it seems like a foreign language. So let's start with the idea in the first part of the sentence where it deals with twice a number is decreased by 7. Okay? Anytime you hear twice a number, it looks like this: 2n, twice a number, and it is being multiplied. Okay, so if you hear 4 times a number, 5 times a number, 6 times a number, it's just simply that number times an unknown. We don't know what this is. It's 6 times a number. So we're going to find out what n is equal to. Okay, with that understood, let's look at the idea here of 2 twice a number is decreased by 7. Well, the idea of decreased is simply minus 7. All right, twice a number is decreased by 7. That is the first part of this sentence till the comma. All right, now it says, and this quantity is multiplied by 3. Well, what quantity? Well, it talks about this whole quantity of twice a number times 7 is multiplied by 3. And we can do it this way. You could also put the 3 on the front side, but to stay in order, okay, meaning of the sentence multiplied by 3, that brings us to the first sentence. The first sentence is complete by this equation. All right, so we are twice a number is decreased by 7 and multiplied by 3. The second sentence says, the result is 9 less than 10 times a number. I always start with the idea of this, like the first statement, 10 times a number. So the result, that word literally means equals. The result is 9 less than 10 times a number. Well, I heard 10 times a number, so I can put that in. And the idea of 9 less means that I'm going to subtract 9. 9 less than what? Than 10 times a number. You can do it this way. You can write the second half of the equation. The result is 9 less, and if you want to start with 9 less, I always put it on this side of the equation. Then what? Then 10 times a number and fill in the rest of it on this side. It's the same thing, but maybe the order is just a little bit different, okay? Now you're going, okay, I don't know how to actually solve this problem. Well, if we have twice a number is 3 less, or excuse me, that should be 7. 7 is multiplied by 3 is 10 times a number less 9. What we can do is use distributive property here with this 3 and this 3. And it has to distribute to both things individually because they're two separate entities. So 2n times 3 is 6n minus 21 equals 10n minus 9. All right, let's combine the n's and combine the other numbers. So let's move this 9 by adding 9 here, by adding 9 here, and let's subtract 6 and subtract 6. So we have 4n, and then 21 and 9 is going to give us a negative 12. We divide by 4, we divide by 4, and is going to equal negative 3. Okay, so we can solve for that. So you're looking at those kinds of equations and how to solve those kinds of problems. The other one that they give you, example 5, says number of ducks on a pond. Okay, it says the number of ducks on the ponds was doubled in 5.2. Number of ducks. I'm going to do number of ducks like this. If number of ducks is doubled, that means it's the same as what we saw last time of twice a number. Number of ducks is doubled. That means we're multiplying this. Number of ducks was doubled when the new flock landed. Then 7 more ducks came. Well, what does that mean? We add 7 more ducks. We don't have to put number of ducks because it told us that 7. This one said number of ducks in the pond was doubled. So we don't know what that number is. This one said 7 more came. So we do know a definite here. Okay. Moving on, it says the resulting number of ducks was 13 less. Well, remember, if it's 13 less, then it's a negative 13. 13 less than what? Well, the statement says 3 times the original number. Well, what's 3 times the original number? It's 3 times, we don't know, number of ducks. This is the original number. So this is what our equation looks like. So we can solve 2 number of ducks plus 7 equals 3 number of ducks minus 13. All right, let's subtract 2 number of ducks. And let's add 13 and add 13 and solve. This cancels out. We have 20 on this side, and we have 1 number of ducks here. We divide by 1, we divide by 1. So number of ducks is equal to 20. And we can put that back into this and see if it satisfies it, and it does. So you'll see those kinds of questions in your lesson today, and just kind of pay attention to the wording, okay? 5b. Let's go to 5b. 5b talks about fractional parts. And again, this is kind of the idea that there's a word problem. And if you look at 5.4, it's a good example of what it is. It says 1/5 of clowns, okay? And I'm going to put 1/5 of C, clowns, had red noses, okay? Well, who cares about red noses, okay? But apparently that's what clowns do, right? So 1/5 of clouds have red noses. And it says, if 30 clowns had red noses, how many clowns were there in all? Well, we don't know. We only know 1/5 is equal to 30, right? Because 1/5 equaled 30, and both of these dealt with the red noses. So how do we know what's left? Okay, so we can set this up with an equation. So if we write the statement 1/5 of clowns is 30, we would actually write it, clear this off so that we can get a clear spot here. 1/5, not 1/3, 1/5 of, or times, the word of equals times clowns equals 30. What we don't know is the total number of clowns. We know red noses and red noses. So essentially, how do we get clowns by itself? Well, if we multiply by the reciprocal here, okay, this cancels out, and what we're left with is clowns equals, and then if we take this operation on this side and do the same thing, 30 times 5 is going to give us 150. So clowns total equals 150. Well, how do you check it? How do I know that 1/5 have red noses? Well, 30 over 150 should reduce down to 1/5, and it does. If we divide by 3, we divide by 3. That is equal to 1/5. So our equation here of fractional parts work. Okay? Let's look at the example of 5.5. It says 7/8 of the Tartar horde rode horses. If 140,000 were in the horde, how many did not ride horses? Okay, so fraction times of equals is. All right. In other words, 7/8 of Tartar horde rode horses. If 140,000 were in the horde, so it gave us a total, then we need to know the opposite of that. So we need to know what the 1/8 did. So 1/8 times the 140,000, okay, over 1, equaled the number of riding horses. Okay, so how do we do this? Well, if we're multiplying, we just multiply across. So it's 140,000 over 8, and if we divide that out, we will come out with 17,500 who basically rode the horses. Okay, so again, pretty simple in this this idea. Hopefully, you will be able to get this with not a problem and enjoy your lesson. All right.